This presentation will explain how to test the accuracy of the comb scanner. When testing the comb scanner in a controlled setting, it's important to keep in mind three variables: the testing environment, scanning procedure, and data analysis. If not controlled for, each of these variables may have a large effect on the outcomes or measurements taken with the comb scanner. Let's go through them one by one. First, the testing environment. We recommend positioning an object on a rotating platform in front of the scanner, and also placing the scanner a set distance away from the object. Typically, the set distance we recommend is 6 to 12 inches. Next, the scanning procedure. The entire object must remain in frame throughout the scan. The object must not move throughout the scan, and you must scan slowly, continuously, and from a constant range. Last, the data analysis. When comparing digital circumferential measurements between hand measurements, ensure that the perpendicular CAD axis used is exactly aligned to the axis used by the tape measure. When comparing digital point-to-point measurements, you must ensure that you are utilizing the center of the tracking dot as your reference marker. Here are three visual examples to explain the testing variables further. A proper testing environment is shown on the left. Notice how the iPhone is mounted at a set distance from the object and that the object is placed on a rotating stool. When the scan operator begins the scan, they will use the rotating stool to slowly revolve the object within the camera's field of view. As a rule of thumb, using this setup, each 360-degree revolution of the stool should take approximately 60 seconds to complete. Next, an example of a good and bad scanning procedure is shown in the middle of the screen. It's critical that the entire object remains in the camera's field of view throughout the duration of the scan. The grayscale image exemplifies an object that is too close to the scanner. Scanning too close to the object may result in an inaccurate scan. Last, the data analysis. If you're comparing digital circumferential measurements between two scans, you may notice inconsistency between the two measurements. This is commonly caused by axis misalignment. Due to the nature of taking circumferential measurements in CAD, unless two axes are exactly aligned between the two scans, the slight difference of angles between the two axes will likely attribute to some error. Following these best practices, the engineers at Comb found the scanner to be accurate up to 1.5 millimeters. Please contact info@combscan.com for the full testing report. During testing, we found significant sources of error when comparing digital to hand measurements, specifically for circumferential measurements. This is because if the perpendicular CAD axis is not exactly aligned to the axis used by the tape measure, circumferential measurements will not be equal between the two. If you're comparing the comb scanner to another type of scanner, a similar source of error applies. Each time a new scan is rendered, a new axis is created in your measurement software. If the axes are not an exact match, you will have a slightly different circumferential value readout. The most important thing to remember with Comb is that the comb scanner can fit patients with functional devices and create high-fidelity models. Like hand casting and plaster casts, the success of the fit results from the post-modification skill. Digital workflow makes this process more accurate since scanning is consistent and repeatable compared to the variables of hand casting. At Comb, we believe that digital measurements will replace hand measurements in O&P and will eventually become the new gold standard. Hand measurements, specifically circumferential, are commonly inaccurate for numerous reasons. There's tape measure tension, user-to-user variability, tape measure wear and tear, soft tissue deformation, and axis misalignment. Digital measurements, while subject to axis misalignment, are stable person to person, stable scan to scan, avoid soft tissue deformation, and do not require a tape measure. For more information on adopting the comb scanner as your primary scanning tool, we invite you to speak with our clinical supporters in O&P who have done so already.